Proper installation of soil water sensors is critical for obtaining accurate measurements. In this video, I'll discuss best practices for installing CS650, CS655, and CS616 water content reflectometers. I want to install the sensor into the soil with the stainless steel rods as parallel as possible with complete contact between the soil and the entire length of the rods. I also want to avoid any preferential flow of water that could affect the soil water content measurements. Although the sensor rods can be inserted vertically into the soil surface or buried at any orientation to the surface, Campbell Scientific recommends installing the sensor horizontally. This allows it to detect the passing of wetting fronts, and for CS650 series sensors, positions the temperature sensor at the same depth as the water content measurement. For this installation, I need the following equipment: a shovel to access the level of soil where I want to make the measurement, a tape measure to measure the distance between the soil surface and the sensor, a notebook and pen to record field notes, a hammer to drive the sensor into the soil. Never forcefully strike the sensor with a hammer, as it will damage the electronics. A board to place above the edge of the hole where the sensor is to be installed. This is used to determine the soil surface and protect the undisturbed soil below it. A laptop computer with the device configuration utility installed, with an A200 attached by a USB cable. The optional CS650G insertion guide is available to create pilot holes and probe for obstacles in the soil. This is especially helpful if the soil is dense, dry, or rocky. The best way to ensure that the soil surrounding the sensor rods is at field density is to prepare a face of undisturbed soil at the desired measurement depth. After selecting a site for sensor burial, remove the vegetation and dig a hole slightly deeper than the lowest measurement. Make the hole large enough for a horizontal sensor and small swings of the hammer. For depths greater than 1 meter, the hole must be large enough for a person and any safety measures needed to keep the soil walls from collapsing. Place the board over the side of the hole where the sensor is being installed to prevent collapsing the edge of the hole. The bottom of this board also serves as the reference point for the soil surface. Use the shovel to shave one wall of the hole, leaving an exposed face of undisturbed soil. When installing multiple water content sensors in the same hole, start at the deepest depth and work toward the surface. If using the CS650G insertion guide due to hard or rocky soil, place the rods of the insertion guide at the desired depth and tap gently with the hammer until the rods are completely inserted into the soil face. Short, gentle taps will protect the CS650G from damage if one of the rods encounters a rock or other obstacle in the soil. If an obstacle keeps the CS650G from going further, remove it slowly and try another nearby location at the same depth. After the CS650G is fully inserted into the soil, remove it slowly by pulling on the strap. The soil is now ready for the water content reflectometer. Check the white label on the sensor cable to make sure the cable length is correct for the depth of interest. Remove cable ties, and if using electrical conduit to protect the cable, run the cable through the first section of conduit now. If the 650G insertion guide was used, place the end of the CS650 rods in the pilot holes. Otherwise, use the tape measure and measure down from the bottom of the board to the desired installation depth and hold the sensor horizontal to the ground at that location. Use the hammer to gently tap the sensor into place. This may cause some deformation of the holes. To correct this, push the sensor slightly into the soil face. If that is not possible, make a small amount of mud and push it into the holes before pushing the sensor to the face. Measure the depth from the soil surface to the sensor and record it in the field notebook along with the sensor identifier. To avoid any preferential flow of water that could affect the soil water content measurements, make a small bend in the cable that drops below the level where the sensor is installed. This creates a drip line that will keep preferential flow outside the sensor measurement volume. Before burying the cable, it's best to connect the sensor to the A200 and laptop to verify the sensor is sending a proper signal. If the sensor was damaged during installation or has any other problems, a quick performance verification now can save a lot of time and effort later. When backfilling the hole, aim to restore the soil to its original compaction level. Also, return the soil to the same depth from which it was removed to maintain a natural layering of the soil profile. This is best done by adding 5 to 10 centimeters, or 2 to 4 inches, of loose soil at a time and tamping it. Be careful to avoid damaging the sensor head or the cable. After all sensors in the hole are buried, finish running the cables through conduit and make the permanent connections to the data logger or multiplexer wiring panel. By following these steps, common measurement errors are avoided and the most accurate water content readings possible can be obtained.